As of now, we've spent some time talking about the syntax for propositional logic, and in this video, I want to start talking about the semantics. The term semantics in general means pertaining to meaning. And when it comes to this system that we are going to be dealing with, there are two senses in which we assign meaning or semantics to sentences of the system. One sense has to do with what we think of these sentences, as we're calling them, as representing. And maybe a better word for it would be what we think of them as an analogy for. And so maybe it won't be too surprising that we think of our sentences of our formal language as representing or analogizing statements of ordinary language. If I could just step back for 1 second here and talk about the big picture of what we're doing. We're interested in deductive reasoning as it occurs in actual statements of English. And deductive reasoning is normally expressed in normal, ordinary language, whatever language you speak, for us English. And the overall idea of what we're doing in creating this symbolic system that you might be thinking is kind of weird is that we're going to create a system in which deductive relationships happen that are analogous to deductive relationships in actual reasoning. But we're going to be able to have a much fuller understanding of how those deductive relationships occur within the system. And so that will then hopefully improve our understanding of the actual deductive arguments. So as I said, one key sort of element of this is that we think of these sentences of this formal language as being a representation or an analogy to statements of ordinary language. The other sense in which we assign a semantics to our formal language is what's sometimes called formal semantics. And all that means is that we provide a semantic value of some kind for each sentence of the system. Our system is going to have two semantic values, true and false. And hopefully it'll become clear why we would choose such values. Now, the first thing we're going to provide semantic values for within our system is the simple sentences. A simple sentence represents a simple statement. And I know you must be thinking, holy cow, are you serious? A simple sentence represents a simple statement. Well, you might have guessed that was going to be the case. So if we take one of our simple sentences of our formal language, like A, for example, we might think of that as representing a simple statement. That is, a statement that doesn't have other statements as parts. Something like the statement that Al is home. So we think of A as representing a statement like Al is home. And notice I chose to say it represented a statement, not a sentence of English, because whether you're saying Al is home or whether you're saying something that means the same thing, we're thinking of the A as representing that, the statement that Al is home. You could put it in other words, like you could say Al's at his place instead of saying Al's at home. Or, you could say Al's in the crib, and that, again, is saying the same thing. So we can think of that as Al. Now, don't assume that the letter A has some kind of special magical significance to this statement being about Al, and that Al starts with A. A lot of times I find that I ask students, what does the A stand for? And they say it stands for Al. Wrong. A doesn't stand for Al. A stands for the complete statement that Al is at home. It doesn't even have to involve the word Al. If someone said, he is home, and they're pointing to Al or a picture of Al, we could think of that as being represented by the A. Or maybe even, debatably, if it was a statement in another language, if we have the statement lui a casa, and it means the same thing as saying Al is home, then we could represent that with A. There isn't anything essential about the fact that I'm using the letter A and it's a sentence that has the word Al in it. I mean, if we have a sentence of Korean and it's spelled this way, chibe so, it's clearly got nothing to do with the letter A, but that's still what we're representing with our A. So it's not something special about the word Al, although admittedly we do choose A because we'll remember that that goes with the statement that Al is home. Now, in terms of our formal sort of systematic semantics for our system, each of the simple sentences of our system is just going to get directly assigned one of our two semantic values. And that's either true or false, which we'll often be abbreviating as T or F. And let me just reiterate, those are just directly assigned. So we have our capital letters A through Z, and each one of those is going to have a truth value. When we talk about it having a certain truth value, sometimes people say, where does that come from? And the answer is, we don't care. It just comes from somewhere. It's assigned somehow or another, one of the two truth values. And from the point of view of just creating a formal system, we could choose whatever we want for semantic values. So we could choose true and false, or we could just have true. Just make every sentence of our system true. Or we could just assign numerical values. We could make the semantic values of our sentences 0 and 1. or we could make them 0 and 1 and 2. But obviously there's a reason why we're choosing these two semantic values, because we want our system to work in a way that's similar to the way that actual statements work. And if you have a simple statement like Al is home, it seems intuitive that that's either going to be true or it's going to be false. Maybe you would have to think of a simple sentence as being sufficiently specified, so maybe we have to really think of Al is home as meaning at an exact moment that someone's speaking. Al is at a specific location or something like that. But intuitively, if I make a simple statement and it's sufficiently specified, it's either going to be a true statement or it's going to be a false statement. So that takes care of the simple sentences. Now, on to the compound sentences, the sentences that have other sentences as parts. And the first kind of compound is a tilde sentence. What I mean by a tilde sentence here is a sentence that has tilde as the main operator, which we understand in a purely syntactic way. And we think of tilde sentences as representing what we call negations. A negation, intuitively, is a statement of the opposite of another statement. So if we said Al is home is going to be represented by A, then tilde A would represent the statement that Al is not home. So it's the denial of the original statement. And again, there would be other ways of putting this in different words. You could just say Al ain't there, or it's not the case that Al is home. That seems like a particularly convoluted way of saying that Al is not home. But sometimes it's convenient to state negations using the phrase it's not the case. And actually the syntax of our formal system is even a little similar to that. Now, in terms of the formal semantics for tilde sentences, there are infinitely many tilde sentences of our system, as you already know. So how can we assign all of these tilde sentences a semantic value? We do so by means of a rule. And let me start by stating the rule verbally. I'm going to use, again, the tool of a metalinguistic variable in order to state my rule. Because what I want to say about tilde sentences, I want to apply to any tilde sentence. So not just tilde A, but tilde B, tilde C, tilde A, and any other tilde sentence. So I'm going to say that the semantic value of tilde P, and again, P could be anything here, is the opposite of the semantic value of P. And I suppose I have to mention the stipulation that our semantic values of true and false will be considered opposites. I've stated the semantic rule concerning the tilde sentences verbally, but we can also think of this rule as stipulating a sort of input-output relationship, so that the value of tilde P is determined by the value of P. And we can think of this in terms of a table of input and output values, or a function. So P is some sentence of our language, and we've stipulated that each sentence of our language is provided one of the truth values. So P is either true or it's false, no matter what it is. And our rule stipulates that if P is true, then the value of tilde P will be false, and if P is false, then the value of tilde P will be true. So you can think of this in terms of a table like this. It's more visual that way. You know, they tell me that all the students are visual learners these days. Seems kind of strange to me. I think in terms of a verbal rule, I don't think of this table in my head and then come up with the statement of the rule that tilde P is the opposite of P. I think tilde P is the opposite of P. That part's easy for me to think of, and then I could generate the table based on that. But however you want to think of it. Now the next operator is the dot, and dot sentences represent what we call conjunctions. So a sentence like A dot B might represent the statement that Al is home and Bob is there too. Intuitively, the idea of a conjunction is when you say two things are true. This time I want to go straight to the formal semantics before talking about other English versions. And let's give our formal semantics for dot statements in terms of the truth table right away. The value of any sentence P dot Q, any sentence with dot as the main operator, will be determined by two values, the value of P and the value of Q. So whereas tilde sentences have their value determined by just one other sentence, dot sentences have their value determined by two input sentences. The first thing we need to do is think of all the possible combinations of semantic values for our two input sentences. When we just had one input sentence P, it was either going to be true or it was going to be false. But now we have two sentences, and we have to consider all the possibilities. Now, there's a systematic way of doing this, but for now, you should be able to see there are the following possibilities. They could both be true, the first one true and the second one false, the first one false and the second one true, or they could both be false. That's all the possibilities there are. Now we have to define what we want our output to be in each case, the value of P dot Q. This is a stipulation, but we're not going to just pull this out of nowhere. We have a goal in mind. We want the dot sentence to work the same way that sentence, Al is home and Bob is there, works. So let's consider the possibilities row by row. If I look at the first case here, where both the input sentences are true, so for example, Al is home, that's true, and Bob is there is also true, then the person who says Al is home and Bob is there said something true. So I'm going to define the output in this case to be true. And then in the other cases, the case where Q is false, or the case where P is false, if one of those statements was false, and I said Al is home and Bob is there, well then the total statement that I just made isn't true. If only one of them's there and I said they're both there, what I said is false. And if both things are false and I say if I say they're both true, then definitely what I said is false. So our resulting truth table looks like this. And if we were to sum this up verbally, I would say that a dot sentence is only true when both of the input sentences on either side of the dot are true. So now let's think about other ways that we could say the same thing. If you have a statement like Al is home and Bob is there, you can also restate that using a compound subject, right? You can say Al and Bob are there, or at Al's, if that's the place we're talking about. There's an important warning about doing this, though. You cannot just say, well, wherever I find the word and, I'll just replace that with a dot. And here's why. If we have the statement that Al and Bob are cousins, that's semantically very different from saying that Al and Bob are at Al's. You can see this by imagining taking a statement and trying to break it down into two statements and see how it works. When I say Al and Bob are at Al's, I can break that down into saying that Al is at his place and Bob is at Al's place. So two separate statements. But if you take the statement Al and Bob are cousins and imagine breaking that down in a similar way, you get Al is a cousin and Bob is a cousin. But that isn't the same as saying Al and Bob are cousins. Because Al and Bob are cousins means that they are cousins of each other. It's asserting a relationship between them. And a dot statement doesn't capture that kind of relationship. So this statement that Al and Bob are cousins is actually not a conjunction, even though it involves the word and. If we wanted to represent this statement within our system, we would have to just think of it as a simple statement, and we could represent it by a C. Now here's another oddity associated with dot sentences. Let's make a comparison between some of these statements that use and the use of the word but. Now if I say that Al is home, but Bob is there too, you might notice that conversationally speaking, is different from saying Al is home and Bob is there too. There's a suggestion of surprise. When I say but Bob is there too, I'm indicating surprise at the fact that Bob is there with Al. Although you don't exactly know what the surprise is about. Why is that surprising that Bob would be there? Are they not friends or something? However, think for a second about the truth conditions of the statement. That is, what does it take for it to be true when I say Al is home, but Bob is there too? If either one of them is not there, then I said something false. And also, if they're both there, didn't I say something true? Maybe it was inappropriate of me to be surprised that they're both there, but that doesn't mean I'm saying something false. My use of the word but here seems to express my own surprise that both these things are true, but it's not like I'm asserting that it's appropriate to be surprised or anything like that. It doesn't seem right to say I said something false, even if it shouldn't be surprising. So what that means is that we can also represent a statement like this with the dot. All our system really cares about is the question, what does it take for this sentence to be true? And it looks like the answer is just both of these component sentences have to be true. So we've got a few different types of sentences we can represent using the dot. But remember to watch out for sentences like Al and Bob are cousins that assert some kind of relationship or that a combination of things has a certain property. So much for the tilde operator and the dot operator. In the next couple of videos, we'll go through the remaining three operators in our system.